Alright, so we're going to look at part 2 of our question, which is finding out the number of bolts required to transfer the section capacity that we found in part 1. And the section capacity that we found in part 1 in tension is 1,550 kilonewtons, and this is our design capacity. So firstly, we need to make some assumptions. The first one is to ignore other failure modes. Now remember that when we look at connections, there are multiple failure modes, and any one of them can be lower than bolt and shear, which is what we're going to be looking at. So we're just going to ignore the other failure modes and just assume that they are strong enough to hold the connection down, and that our bolt will be able to transfer the full section capacity of 1,550 kilonewtons. Alright, so moving ahead. We will be using the equation VF equals to 0.62 times KR, and then in brackets NN times AC plus NX times A0 times the tensile strength of our bolt. Now when we begin, KR will be the first variable that we encounter, and KR is dependent on the length between the first row of connectors and the last row of connectors. So in our equal angle, it would be between the first bolt and the last bolt. So because we don't actually know the number of bolts and we're trying to solve for it, we have to make an assumption to begin with, and then we check back at the end. So for the sake of answering this question, we'll start off with 1.0 as our assumption, and